Welcome to HardHat Engineer. In this video, you'll learn about different types of flow meters in process piping. You will learn about these 8 types of flow meters such as Orifice, Venturi, Coriolis, Magnetic, Turbine, Ultrasonic, Vortex, and Rotameter. You will also learn about components, uses, advantages, and disadvantages. Let's get started. Accurate fluid flow measurement is essential for effective process control. To achieve this, various types of flow meters are used in process industries, considering factors such as fluid type, pressure, temperature, accuracy requirements, and cost. What is the Orifice flow meter? The Orifice plate flow meter is a device used to measure the flow rate of fluids like liquids, gases, or steam. It works by placing a plate with a hole orifice in the path of the fluid to create an obstruction in a pipe. This creates a restriction, which causes a drop in pressure across the plate. Here in the image you can see that. The difference in pressure before and after upstream side to the downstream side. The plate is directly related to how fast the fluid is flowing, and this is measured to determine the flow rate. The main components of this system are the orifice plate itself and a differential pressure transmitter, which measures the pressure drop. Orifice plate flow meters are commonly used in industries like oil and gas and chemical processing. There are different types of orifice plates, such as concentric with a hole in the center, eccentric with a hole near the edge, and segmental with the part of the plate cut out. The main advantages of using this type of flow meter are its simple design and low cost. However, it also has some drawbacks, like causing a permanent pressure loss in the system and being sensitive to flow disturbances, which can affect accuracy. What is the Venturi flow meter? A Venturi flow meter is a device used to measure the flow rate of fluids by narrowing the pipe through which the fluid flows. As the pipe narrows, as shown here in the image, the velocity of the fluid increases and the pressure decreases. This pressure drop is measured and used to calculate the flow rate. After the pressure difference is generated, the fluid passes through a pressure recovery exit section, where up to 80% of the differential pressure generated at the throat is recovered. The key components of a Venturi meter include a Venturi tube, the narrowed section of the pipe, and a differential pressure transmitter, which measures the change in pressure before and after the narrowing. Venturi meters are ideal for measuring large flow rates and are often used in applications involving water and gas. They are known for their high accuracy and have the advantage of causing minimal pressure loss in the system. However, they are more expensive than other flow meters and require a considerable amount of space for installation due to their design. If you want to learn more about various process control instruments, you can check my full course. It is extremely affordable with lifetime access and comes with a 30 days, no question asked money back guarantee. So don't forget to check. The link is given in the description. What is the Coriolis flow meter? A Coriolis flow meter is a device that directly measures the mass flow rate of a fluid by detecting how the fluid flowing through oscillating tubes affects their vibrations. As the fluid moves through the vibrating tubes, it causes slight changes in the tube's motion, which sensors can detect. Fluid moves through the tube and is forced to take on the vertical movement of the tube in one direction on the inlet side and in the opposite direction on the outlet side, causing a twisting Coriolis effect of the tube. These changes are used to determine the mass flow rate of the fluid. The key components include the oscillating tubes where the fluid flows, along with sensors and transmitters that monitor the vibration changes and convert them into flow rate measurements. Coriolis meters are widely used for measuring the mass flow of both liquids and gases, especially in industries like oil and gas, chemical processing, and food production. Their major advantages are the ability to directly measure mass flow with high accuracy. However, They tend to be expensive and are best suited for clean fluids, as they may not perform well with fluids containing particles or contaminants. What is the magnetic flow meter? A magnetic flow meter or magmeter measures the flow of conductive fluids using Faraday's law of electromagnetic induction. When a conductive liquid passes through a magnetic field created by coils, it generates a voltage. Electrodes placed inside the pipe detect this voltage, which is proportional to the flow rate, and the transmitter converts it into a flow reading. The key components, as shown here in the image, of a magmeter include electrodes to detect the generated voltage, magnetic coils to create the magnetic field, and a transmitter to process and display the flow data. Magmeters are commonly used in applications like water treatment, chemical processes, and slurry handling because they can handle dirty or corrosive liquids without any moving parts that could wear out. The advantages include durability and suitability for harsh fluids. However, they only work with conductive fluids, meaning they cannot measure non-conductive liquids like oil. Additionally, they can be expensive to install initially. What is the turbine flow meter? A turbine flow meter measures the flow rate by using a rotor placed inside the fluid stream. As the fluid flows through the meter, it causes the rotor to spin. As you can see here in the image, the speed at which the rotor spins is directly proportional to the flow rate of the fluid. A pickup sensor detects the rotor's rotation and converts it into a flow measurement. The main components of a turbine flow meter are the turbine rotor, which spins as the fluid passes, and the pickup sensor, which measures the rotational speed. Turbine flow meters are commonly used in industries like oil and gas, HVAC systems, and water distribution for measuring liquid flow. They offer high accuracy, especially with clean liquids and gases. However, they are prone to wear and tear over time due to the moving parts, and they are not suitable for dirty fluids, as debris can damage the rotor or cause inaccuracies. What is the ultrasonic flow meter? As the name suggests, the ultrasonic flow meter measures the flow rate of a fluid by using ultrasonic waves. The meter sends ultrasonic signals through the fluid, and the speed at which these waves travel is affected by the flow of the fluid. By measuring the change in velocity, the flow rate is calculated. The key components of an ultrasonic flow meter are the ultrasonic transducers, which generate the ultrasonic waves, and a receiver that detects the signals. Ultrasonic flow meters are ideal for large pipes and non-intrusive applications, making them suitable for measuring flow in wastewater, slurries, and other challenging fluids. There are two main types: transit time flow meters, which work best with clean fluids, and Doppler flow meters, which can measure fluids containing suspended particles or bubbles. The advantages of ultrasonic flow meters include their non-intrusive nature, meaning they do not come into direct contact with the fluid, and they cause no pressure loss. However, transit time flow meters require clean fluids to function accurately, and their accuracy can be affected by factors such as temperature and fluid density. What is the vortex flow meter? A vortex flow meter measures flow by using the principle of vortex shedding. When a fluid flows past a bluff body, a stationary object placed in the flow path, as shown here, it creates alternating vortices which are shed downstream of the body. The frequency at which these vortices form is directly proportional to the flow velocity, allowing the meter to calculate the flow rate. The key components of a vortex flow meter are the bluff body that disrupts the flow and a vortex sensor that detects the frequency of the shed vortices. Vortex flow meters are widely used in industries such as energy and chemical processing to measure steam, gases, and liquids. Their advantages include having no moving parts, which reduces maintenance, and their ability to handle a broad range of fluids. However, they are less effective at measuring low flow rates, and can cause some pressure loss in the system due to the obstruction created by the bluff body. What is the rotometer? By far the most simple flow measuring instrument is rotometer, also known as variable area flow meter, measures flow by using a float inside a vertically tapered tube. As fluid flows upward through the tube, it lifts the float. The float stabilizes at a point where the upward force of the fluid equals the weight of the float, and this position indicates the flow rate, as you can see here in the image. The main components of a rotometer are the tapered tube, which widens as it goes up, and the float, which rises and falls depending on the flow. Rotometers are commonly used for measuring low flow rates, especially in laboratory settings and various process industries. Their advantages include being simple, cost-effective, and requiring no external power to operate. However, they are typically limited to applications with low pressures and are less accurate compared to other flow measurement devices. If you have any questions on the topic or want to request a video, please mention in the comment. This is the end of the video. Please like and share this video, and don't forget to hit the subscribe button so you don't miss the next one. If you have a video topic in mind, drop it in the comments below.